Hi everyone, good morning. Can you see my screen, everyone? Can you hear me?
Yes.
Fine. Yeah, so due to some technical issues, yesterday we canceled the session. So today we are going to start servers networks basics. So these are very important. So because before going to cloud platform, first we need to understand basics of servers networks. Fine. So still people are joining. Fine. So let's get started. Yeah. So today we are going to work on servers and networks basics. So am I audible? Can you confirm anyone one more time? Am I audible and my screen is visible? Can you confirm anyone?
Yes, it's
Yes.
visible.
Fine. Yeah. Fine. So introduction to servers and networks. So today's agenda here is what is server, types of servers, and server client model, best practices, server architecture, what is operating system, types of operating systems, what is network, types of networks, what is IP address, what is subnet, what is gateway, router, firewall, failover, load balancer. So these are all very important. Just a minute. Yeah. So these are all very important. Before going to cloud, first we need to understand all these things. Okay. Yeah. Today we are going to we are going to cover up to operating system up to here. This will take nearly 1 hour. Okay. Up to operating systems. Okay. Yeah. Fine. What is server? What is server? Anyone having idea what is server? Server is a computer. Server is a computer. So server is having high computing power, right? Yeah. See here, there is a definition. A server is a computer that serves information to other computers called clients. What is client? So like desktops or laptops. So we use right to connect our applications, our databases, right? Yeah, server is a computer that serves information to other computers called clients can connect to a server through either a local area network or a wide network such as the internet, right? So normally computer this server is having high computing power. So number of modules, memory modules, number of storages, number of processors, right? So we can configure the server in centrally in central in data center. So we host all the applications, databases, and production applications, critical applications, digital applications, all we host in the server only, right? So this server we can access through internet or intranet. So by using, yeah, so we use laptop or desktop to connect our server through internet. Okay, fine. See here, these are the types of servers. So we have three types of servers are available. So blade server, rack server, tower server. What is blade server? So blade server is a modular server. Blade server is a modular server that allows multiple servers to be hosted in a smaller area. So this is a container. Inside of this container, we have these are the blade servers. These are the modular servers, modules. So these are the modules. Just a minute, please. People are pinging, keep on pinging. They're unable to join. Fine. So a blade server is a modular server that allows multiple servers to be hosted in a smaller area, right? So this blade capacity minimum 16 slots. So we can insert 16 slots or 32 or 64 like that, right? So in this container we insert this blade servers, thin servers. These are the thin servers. These servers are having high computing power, right? And also some of the blade servers will not have any storage, right? Only processor, memory modules are available in the blade servers. But without storage, how can we store the data? Without storage, how can we store the data in the blade server? So we connect external storages. We connect external storages. So these servers are physically thin, typically only have CPU, memory, integrated network controllers, and sometimes storage drives built in. Sometimes, okay. Yeah, blade servers often seen in large data centers like Google data centers, right? UHG. So I worked with Verizon data services for 8 years, right? So we used to use the blade servers. Verizon is a telecom domain, right? So which is one of the product-based company. So we used to use blade servers to host the applications. Okay. So in large data centers, enterprise level, we use the blade servers. So blade servers are a bit costlier compared to other servers. These are high performance servers, right? So memory 256 GB memory, right? Yeah, like that high computing power. So processing is also quad core, octa core. So like that, the processing speed available in the blade servers, right? So next one is rack servers. A rack server is a server mounted inside of a rack. So rack servers are typically general purpose servers that support a broad range of applications and computing, right? So most of the data centers we use the rack servers only. Most of the data centers, right? So this rack is having 48 ports, 48 slots, and 32 slots like that. So 48 servers we can insert into the rack, right? It is one of the big container. So inside of this, we can insert servers. We can connect power network, right? So we can connect one monitor also, keyboard also to check the issues. If you want to restart your server, if you want to configure anything, if you want to deploy any packages, so we connect the keyboard, monitor, mouse also. So this rack. So we can take control and we can operate the servers, right? Yeah. Next one is a towered server, which is bit older server. A tower server is a computer that is built in an upright cabinet that stands alone and that is designed function as a server. So this is the bit oldest server. So currently we are not using. So this is the tower server, only one CPU, one server only configured in this tower. So for this we connect one monitor, so keyboard, right? So we can configure this, right? So this is a bit older server. Currently we are not using. Currently most of the data centers we are using rack servers and blade servers. Okay. So client server model. So client server model. See here. So these are the clients, desktop or laptop. We can connect our servers through network. So by using desktop or laptop, we can connect our servers through network only. So when we send request, server will give response, right? Yeah. So either it can be LAN or MAN or WAN, so or PAN. Different networks are there. Those networks we'll discuss tomorrow. LAN, local area network; MAN, metropolitan area network; and WAN, wide area network; and PAN, personal area network. 4 networks are there. So we'll see tomorrow. Okay. Yeah. So see here, this is another client server model. So either we can connect our servers by using a laptop or desktop, or even we can use the tab also to connect our server through internet. Okay. Yeah. Server architecture. Server architecture is a foundation layout or model of a server. So based on which a server is created and are deployed, right? It defines how server is designed. So let's try to understand few examples here. Server, we are talking about server architecture, right? Server architecture, initial phase of implementation, or we can say first phase of implementation. First phase of initial phase of implementation or first phase of implementation. Yeah. So what is the initial phase of implementation? Okay, so normally, so when we talk about server architecture, yeah, in 90s and early 2000, in 90s and early 2000, 1990s and early 2000, how the server architecture designed, how the server architecture, how was the server architecture designed? Okay, yeah. So by the time 1990s and early 2000, highest capacity of the storage is 1 GB. In 19, I'm talking about in 1990s, okay, and early 2000. So I completed my engineering in 1998. Okay, so by the time we used to use very low capacity storages in our lab. So we used to use very low capacity storages. Highest capacity of storage is 1 GB, right? So for example, we have 4 applications are there like Java, Tomcat, Python, and also we have other software like Git, for example. Currently, by the time, so we don't, yeah. So other we can say C, C++, for example. So in 1990s and early 2000, yeah. So Java, Tomcat, Python, C, C++. Okay. So four, yeah. These are the 4 applications, for example. Okay. So in 1990s and early 2000, so when they want to build any servers, the project team, they used to take, for each application, they used to take one server. Okay. For each application, they used to take one server. So we have 4 applications are there. They used to take 4 servers like this. For 4 applications, 4 servers. So these servers are 1 GB capacity servers. So 1 GB storage capacity servers, right? Fine. So here 4 applications, 4 servers. So here they deployed Java, for example. So Java will be occupied, for example, 300 MB, for example, 300 MB, right? So remaining space will be wasted, right? So remaining 700 MB space will be wasted. So here 700 MB. So 1 GB means 1000 MB, right? 1024, 1024 MB, 1 GB means, right? Yeah. So remaining space will be wasted. So here Tomcat occupied 350 MB, for example, 350 MB. So remaining space will be wasted here. Remaining 650 MB space will be wasted, right? And also Python occupied 400 MB. So 600 MB space will be wasted here. So in 1990s and early 2000, project teams used to take for one application, one server. Okay. Yeah, 600 MB space will be wasted here. So next one is C, C++. So occupied here 450 MB, for example. Remaining space will be wasted here. 550 MB will be wasted. Right. So like this, they used to take one application, one server. For one application, one server, right? Yeah. So here what happened? What happened here? So by the time, so utilization is very less. Server utilization is less. Costing, hardware costing, it was very higher by the time, right? So in 1990s and early 2000, so even desktop costing 1 lakh, 1,50,000 like that, right? So based on the configuration, right? So server costing, it too much cost. It was too much by the time. So people, the project teams used to spend more budget for the hardware, right? So here server utilization is very less. Server utilization is very less, and the costing is a very, it was very higher, right? So that is why this is the failed concept. This concept is failed. This was failed. Okay. So this is a 1990s and early 2000. The project teams used to design the servers like this. This is the first phase of implementation. First phase. So in second phase of implementation, what happened here? So project teams used to take one high-end capacity server. Project teams used to take one high-end capacity server. They used to deploy all the applications on same server. Okay. So here, these are the applications like Java, Tomcat, Python, and also C++. Right. So project teams used to take one high-end capacity server. So they used to deploy all the applications on the same server. Right. So here what will happen? Java user, he can access Java application. He can log into the server. He can access the Java application. Tomcat user, he can log into the server. He can access the Tomcat application. So Python user, he can log into the server. He can access the Python. So this user, C++, he can log into the server. He can access the application. So here, fine, they are working on the same server. They are using their respective applications. They are working, some development activities going. So they are working on their applications, right? So here what happened? Java user may access Tomcat application. There may be chances to access. So Tomcat user may access Python application. There may be chances to access. So Python user may access the C++. There may be chances to access, right? So because 4 people are connecting to the same server, so they're using the same server. There may be chances to access other applications also. Security will be there, but still there may be chances. For example, so in one flat, 4 people are staying. 2 BHK flat, 4 people are staying. Okay. So 2 people are staying in one bedroom, 2 people are staying in other bedroom, right? The 4 people commonly access kitchen and dining, right? The same way, so 4 people are logged into the same server, so they can access their respective applications. Along with that, there may be chances to access other applications also, right? Yeah, so that is one of the drawback, right? Security concern. And also, in case this server is crash, what will happen? This server is crash, what will happen? All the applications will be gone. You understanding, right, everyone? So here we have drawbacks are there, right? So high-end capacity they used to take, and they used to deploy all the applications, not only 4 applications. They used to deploy all the applications. So every engineer, every developer, they connect the server, they work on their respective activities. By the time, in case the service crash, okay, so service crash, all the applications will be gone, and also there may be chances to access other applications also. These are the drawbacks. That is why, so this is also failed concept. This is also failed, right? Yeah. So next one, in third phase of implementation, what happened? Slowly, in third phase of implementation, what happened here? Virtual servers came into the market. Virtual servers, virtualization. So what is virtualization? Anyone having idea? Anyone having idea? Virtual server architecture.
Other than physical.
Yeah. Virtual server architecture, right? So slowly, project teams move to virtualization, virtual servers. Okay. So in virtualization, virtual servers, what happened here? Project teams still we are using virtual servers. In the projects, still we are using virtual servers, right? Yeah. So here what we will do, we take one high capacity server. This we can say base OS, base operating system. Okay. So on top of this, what we will do, we deploy one application, one package. which we can say VMware or hypervisor, Hyper-V or Citrix. So this is virtual software. This is virtual software. So once we deploy this virtual software, this will allow you to create virtual servers. What is virtual server, anyone? What is virtual server? Online guys, what is virtual server? Anyone? What is virtualization? Anyone having idea?
Yes, and instead of hosting physical server and networks in the same only, we will give that virtual.
Right. So virtual server is a imaginary server which is not physical, right? So same functionality, physical server and virtual server. So we can use the server. So same functionality, right? Server side we can access all the applications and all. So everything is same. But virtual server is a imaginary server, so which is not physical, right? Yeah. Now see here. So on top of the base server, we deploy VMware or hypervisor or Citrix. So this will allow you to create virtual servers. Like this, we can create virtual servers. See here. So based on the physical server capacity, we can create the virtual servers. So these are all virtual servers. So here we have 25 servers are there, 5 into 5. So we can deploy different operating environments here, like Windows 2022 latest version, Windows Server. And here we can deploy RHCL, Red Hat Enterprise Linux. Here we deploy SUSE Linux. Here we deploy Ubuntu. Here we deploy CentOS. So these are all Linux flavors. Right? So flavor is nothing but version, right? So different flavors are available here, Linux flavors. Fine. So here 5 into 5, 25 servers are there here, right? So in this we can deploy different operating systems and we can connect these virtual servers. So virtually we can connect. Okay. Yeah. So here, so when we want to deploy operating system, when we want to install operating system, we use ISO image. So when you want to deploy operating system on physical server or virtual server or laptop or desktop, normally we use the image, right? So ISO, what is ISO? Anyone having idea? So ISO full form here is International Standardization Organization. ISO full form is International Standardization Organization. So ISO image is a master copy of the operating system, right? So normally, for example, if you want to deploy Windows on your laptop, how can you deploy? Anyone? So if you want to deploy Windows on your laptop, how can you deploy? So by using one image, right? We can use the image to deploy the operating system, right? So image is a master copy, right? So that we use to normally if you want to deploy, so either Linux or Windows or any other operating system, right? We use the image. So this ISO image size would be 6 GB to 18 GB. So for server side or desktop side, so normally this size 6 GB to 18 GB only for operating system. If you want to deploy, so we use the ISO image that size 6 GB to 18 GB. Why we are saying 6 GB to 18 GB? So based on the operating system, like so Windows 2022, this will take 17 GB, right? So RHCL takes 8 GB. So Ubuntu 6 GB, right? CentOS 10 GB. Like that, based on the operating system, so this space will be utilized. Okay, yeah. So here 5 into 5, 25 servers are there. So on an average, for example, each server is taking 10 GB, 10 into 25. So here we need to spend 250 GB for only operating system. So 250 GB we need to spend for only operating system, right? So along with that, on top of this operating system, we need to deploy applications, patches, plugins, right? So we need to install all these things. So that will take more space, right? Yeah. So this virtualization storage costing is very higher. It is very higher, right? So we need to spend more storages here, more storage. So use storage. Okay. So only operating system we need to spend 250 GB. So on top of that, we need to deploy all the applications, plugin patches. That takes more space. So this is one of the drawback in virtualization. And also, so when you want to restart or restart your server, this will take minimum 4 to 8 minutes. 4 to 8 minutes. When you want to restart your physical server or virtual server, anything. Okay. So why it will take 4 to 8 minutes? Normally laptop or desktop, when you want to restart, within 1 minute we can restart, right? Within 1 minute. But when you want to restart server side, so this may take 4 to 8 minutes. So once you restart your server, so that will check the memory, integrate network controllers and updates, patches, then only that will be restart slowly, right? Yeah. So this is also one of the drawback. Normally, for example, so in this virtual server we deployed Flipkart application. So Flipkart application, if you restart the server as a cloud engineer, as a DevOps engineer, okay, so the service is taking 4 to 8 minutes. If the Flipkart service is down for 8 minutes, what will happen? So Flipkart business will be impacted, right? So client will not accept for the downtime, right? So restart time 4 to 8 minutes here. And also deployment time and downtime is high. So when you want to deploy any application, that takes more time on the servers. So when you want to downtime, what is downtime, anyone?
Unavailability.
Unavailability, yes. So any other answers? What is downtime, anyone? What is downtime, anyone? Downtime. So downtime is a maintenance time. We can say maintenance time, right? So when you want to down your server, right? So yeah, for example, down means restart or shutdown, right? So when you restart your server, that takes more time. When you want to deploy any applications or code deployment, that takes more time. These are all drawbacks. So first one here is, see here, image size 6 GB to 18 GB, more space. So total 250 GB utilized for the 25 servers. Okay, and also restart time minimum 48 minutes, and deployment time and downtime is higher. So these are all drawbacks. Still we are using virtual servers, but these are all the drawbacks, right? Yeah. Now let's go and discuss about one more architecture, which is latest one, which is very trendy. So currently we are using. So in fourth phase of implementation, yeah, in fourth phase of implementation, we are using Docker containers, Docker architecture, Docker. This is very, very important. So currently, most of the project teams, they are migrating their applications to Docker containers. So this is currently we are using. So currently digital applications we are using, right? Like Flipkart, Amazon shopping site, Myntra, Meesho, right? Trends. So these are all digital applications. So when we book any product, the product will be delivered within 1 day, 2 days. So groceries, when we book the groceries, how much time they are taking? Within 5 minutes, 10 minutes, right? So Flipkart, Jepto, Dunjo, these are all the applications, right? So digital applications. When we book any groceries, within 5-10 minutes we are getting that. How we are getting that? Because backend they have this core technology, core tools, Docker, Kubernetes. Okay, yeah. So this architecture, Docker architecture. See here. So this is my Docker server. This is my Docker server. So Docker is advanced to virtual servers. Docker containers are advanced to virtualization. The people, the project teams, they are migrating their applications to Docker because so many advantages are there here. We'll see that. Okay. So Docker server, we can say Docker. This is Docker server. So on top of this Docker server, we deploy one package same as virtual servers. So which is we can say Docker image. We can deploy Docker image here. Okay. So this image allows you to create Docker containers. See here. So these are the Docker containers. So here we can deploy different operating environments. See here. So here you can deploy RHCL, SUSE Linux, CentOS. Here we can deploy Ubuntu. So here we can deploy Windows. So Windows 20, 22, latest one. Okay. Yeah. So these are the Docker containers. Container in general, container is a box, right? So containers are not servers. Okay. So advanced to virtual servers. These containers are advanced to virtual servers. So when you run the container, when you run the container, so in this container only library and binary files will be created. Library and binary files, lib and bin. Okay. So this container OS operating system sizes, this container, this operating system size is 200 MB only. Container operating system size 200 MB only. OS 200 MB size. Okay. So here when we compare with the virtual servers, this servers are taking 6 GB to 18 GB. But when you run the containers, it is utilizing only 200 MB. So why this much of drastic change? Anyone? Because when we run the containers, so containers are taking only library and binary files only. For example, so if you want to deploy application on a container, so these files are enough. So we don't require any additional files. So this ISO image is full blowing operating system. Full blowing operating system. So we yeah, what does it mean? Full blowing. So when we deploy ISO image, so along with the ISO image, so graphics will be there, paintbrush will be there, notepad will be there, calculator will be there, other features also will be there. So this is a full blowing operating system. But when we run the containers, only library binary files are available. Okay. So to run the applications, these are enough. For example, if you want to deploy Flipkart application, so normally developer develop the code, right? So once development is completed, what they will do, they push the code to respective target servers. Okay. So if you want to deploy that application, right? So this lib and bin files are enough. No need to create other files, right? Yeah. For example, 4 people, they are staying in a flat. Okay. So if they want to live, they required minimal things, right? So if they want to stay, they want to live, so they require minimum things, minimum requirements. What are those? Food, clothes, right? Water, right? So minimum things required if they want to live, right? If they want to live lavish, they require furnishing, AC. You understanding, right, everyone?
Yeah.
For example, normal living, minimal things enough, right? If they want to live lavish, right? So they require all the furnishing, ACs, right? So whatever, right? They require. So this is a normal living. This is lavish. This is bit costlier. This is bit costlier. This is less costing. This is very less costing, very faster. This is very faster, less costing. So both are same functionality. Both are same functionality, right? So normal living and lavish, both are same thing, right? So, but when we talk about Docker containers are very faster and less costing, licensing cost. So client always look for the cost saving, right? So that is why always, yeah, people are looking for the low cost environments, low cost infrastructure, right? Yeah, fine. So one more example I give you. One of my friend is working with Wipro, is working as a DevOps architect. Okay, yeah. So is based out of Hyderabad only. Okay, he's having own house, and he's having yeah, everything is available here. But what happened here? So he moved to Manali, Himachal. He moved to Manali. He's staying there because their atmosphere, client, like, sorry. So he's working as a architect. So he's working from home only, permanent work from home. No need to go to office, right? So in Manali, water and climate is very good, right? So no pollution, nothing, right? He's having kids. He moved to Manali. Now he's lightweight. He's lightweight. What is lightweight? So this containers are lightweight. This infrastructure is heavy. Lightweight is nothing but, yeah, minimal things, right? So whenever we have lightweight, it's very faster. It's very faster, right? And also less costing. So this person, the person who like one of my friend I told you, right? His name Madan. So he can move anywhere from, he's staying in Manali currently. He can move anywhere from there because he's having minimal things only, right? Yeah. So same way, this containers we can move anywhere, we can use anywhere, but servers we can't move, right? So what are the advantages of Docker containers here? OS size is 200 MB only, and also when you restart container, it takes 15 seconds only. So if the container is restarted or not, will not understand. Okay, so 15 seconds, within 15 seconds, the container will be restarted, and also deployment time and downtime is very less. Deployment time and downtime is very less, right? So these are all advantages. These are all advantages, right? Clear, right, everyone? Up to here it is clear, right? Any questions, anyone? Up to here? Anyone having any questions? Anyone? Is it clear to you? So you can ask me questions now. You can ask me questions now. I give you unmute options to ask the questions.
So we discussed the virtual machine, a virtual server, right?
Yes.
So
Yes.
I understand that based on the physical server capacity, we can build a virtual server on top of.
Exactly. Yes. Based on the physical server
Physical
capacity
server,
only.
based on the physical server capacity, we can build up the virtual server, a
Yes.
virtual machine. Okay. When the physical server crash, all the virtual server is crash,
Yes. Good question.
right?
Yes, that
So
is true.
that that means this is the kind of the physical server.
Yes. Yeah, I explained that. So that is the question, right? Any other questions? Anyone? Yeah, fine. Good question. So Dheeraj asking the question that so this virtual servers are taking the hardware from
Yes.
base OS, base server, physical server. For example, here this server is having RAM 64 GB. For example, CPU 32 core CPU. For example, okay. Storage 10 TB. For example. So this hardware utilized by this hardware. So physical server hardware will be utilized by this virtual server. So virtual servers are running on based on the physical server hardware capacity, right? So we can create virtual servers. So based on the physical server hardware capacity, right? So in case this base service crash, what will happen? This service will be gone, right? Yeah, that is why we have a concept called cluster. We use the cluster. What is cluster? Anyone? We use the cluster concept here. Dheeraj, do you know what is cluster?
It's a duplicate of those things.
Right. So real time guys, what is cluster? Anyone? Yeah, cluster is a group of servers. What are the advantages of cluster? This is an interview question. Most of the interviews are, most of the interviewers are asking this question. Most of the interviews, okay. So advantage of clusters for load balancing and also fault tolerance. Load balancing and fault tolerance. Load balancing and fault. What is load balancing? Anyone? Load balancing. So in the cluster, for example, 5 servers we configured, right? So in the 5 servers, applications are running. That load will be equally balanced, right? And fault tolerance, in case one service crash, application will not be down. For example, in simple language, in the project, 10 members are there. Each one getting 30 requests per day. 300 requests they are getting. 10 members. Okay. So in that 10 members, 5 members went on leave. What will happen? That load will be balanced to other guys, right? So each one getting 30 requests, but 5 people went on leave. So what will happen? Each one getting here each one need to work on 60 requests, right? So in case 5 members left from the organization, five members resigned, project will not be stopped, right? Project will not be stopped. So fault tolerance is nothing but in case one service crash, nothing will be happened. Load balancing is nothing but so the load, whatever application load is there, so that load will be balanced, right? So this is interview question. Most of the interviews they're asking, what is cluster? What are the advantages of cluster? So that we will discuss. Practically we'll see this load balancing. Okay, we have load balancing services in AWS, Azure, Google Cloud, right? Clear, right? There is.
Yes, but my question was, when you create the virtual server based on the base server, how it could be the virtual? Because this is the physical servers, we are grouping the based on the capacity, we can define the virtual server. So how it could be this is the virtual server?
Right. For example, we are using AWS servers. AWS servers are virtual servers, right? So virtually we are connecting through internet, right? So in the AWS data center, physical servers are there. On top of that, we are creating AWS servers. Can you speak a bit louder? Yeah.
Yes, yes.
Is it clear to you?
Yes.
Your question is clear? Right.
Yeah.
Any other questions, anyone? So far, any questions, anyone? Fine. So these are the virtual servers. Virtual servers take the resource from the base server. Okay. even though containers also take the resource from the Docker server. So Docker server can be AWS server or Azure server or GCP server. It can be any cloud server, even though we can use the physical server also. But currently we are not using physical servers for Docker. We are using cloud servers only. So cloud servers are virtual servers. Cloud servers also virtual servers, right? So on top of this Docker server, we deploy the Docker image. Docker image allows you to create the containers, right? So this containers concept is very advanced one. So if you are good in Docker or Kubernetes, you can easily crack your entry. So currently,
Yes. Uh, they only manage that physical server, right, sir? In the Docker server, there are three types of servers, right? AWS, Azure, and GCP.
yes,
Yeah, they hosting their physical server.
exactly.
Yeah,
In AWS data center, AWS people hosting the
hosting the
servers. Yes. On top of that,
we will use that Docker server.
yes, right. Virtually we create the
Virtually we create.
Docker server. So on top of that, we can run the containers. Okay, fine. So Docker is very advanced tool. So if you are good in Docker, you can easily understand Kubernetes. Okay. So Docker, Kubernetes, these tools are very core tools. Docker and Kubernetes. Currently,
But
so most of the interviews we are getting these questions, Docker and Kubernetes on Docker and Kubernetes. If you are good in Docker or Kubernetes, you can easily crack your entry along with this one cloud platform. Yeah, go ahead, please. Someone asking some question here.
but without the cloud server, we can use the Docker and we can deploy the application image on the your physical server or any data center or in-house server, right?
Yeah. So currently we are using cloud servers because of the cost saving. First thing, cost saving. So
Mhm.
in the second demo, I explained why we are using cloud currently. What is
Cost
the
saving,
yeah?
time
What is the
Time
importance
and
of
cost
cloud,
for
right? So cost
yes.
saving, time saving.
saving.
So every project team they are using cloud servers because of the cost saving, time saving. So always we are using the cloud servers here. So even physical servers also can be used here for Docker. We can host the Docker in physical server also. In that physical server, we run the container. But that is not using currently. We are not using. Okay.
So
Earlier they
Docker,
tested like that. Yeah.
each Docker hub is the Docker server because we create the image of the application and push the image to the Docker hub.
Mhm.
So
Yes.
can we
You
say
have,
the
I think
Docker
you have
hub
some
is the
knowledge on
Docker?
Docker. Yes, Docker Hub is there. So if I talk technically, people will be confused. There
Mhm.
is wait for some time. So
Okay. No,
Docker
no.
Hub,
Just
two
I am
things are there.
asking. No, just I am
Mhm.
asking. You say the Docker server, right? Based
Yes,
on the
yes.
your physical server, we have the Docker server, or we can create a container
Mhm.
based on Docker server. So my
Yes.
question is, suppose I have any application, we create
Mhm.
the image of the application, and we are pushing the image to the Docker hub, and generally,
Mhm.
right?
Yes,
So
yes,
can we
correct.
say the Docker hub is the Docker server where we create a container and we can post the image?
No, 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 not possible. No, no, no. That is not possible. That is why I'm saying currently we are not using physical servers. We are using virtual servers only. You understand, right?
Yeah.
Currently, most of the positives are using cloud servers only. We are not using physical for Docker, even Kubernetes also.
That's
Okay.
fine. We are not using, but can we use it?
Yeah. Earlier we used to use, but that is big challenge. That is big challenge. Challenges are there. So that is why most of the positives they are migrated. They migrated to cloud. So in physical environment, so many challenges. I worked as a data center admin. I started my career in 2005 with Verizon Data Services. So I used to handle data centers, large data centers. So by the time we used to configure. So, but Docker launched in 2013. So before that, I worked on physical data centers. By the time we used to use this virtualization and all, right? So initially when Docker launches in 2013, by the time we tried that physical environment, physically. but big challenge, so many challenges are there. Okay, so we'll discuss, we'll go very deep dive. So don't worry, we'll see that practical. We'll see that. Okay,
Sure. Thank you.
fine. Yeah. Any other questions, anyone? So Docker and Kubernetes, these are very popular tools, right? So currently, so in the market, very huge demand is there for Docker and Kubernetes. If you are good in Docker and Kubernetes, so you can easily crack your interview, right? So we are going to learn nearly 13 tools, 13 to 14 tools, right? But Docker and Kubernetes, these tools are very core tools, very advanced tools. So Docker launched in 2013. So Docker launched in 2013, right? So Kubernetes launched in 2014, immediately after 1 year, right? So why they launched immediately, right? What are the advantages? What is the functionality? So what are the real challenges? What are the roles, DevOps engineer roles? These are all will be covered in the real sessions, like practical sessions. Okay, so you need to wait for some time. So these are the introductions only, right? Yeah. So Docker, currently we're using Docker containers. Before Docker also, we used to use some containers. Before Docker also, we used to use some containers. So those are different containers. LXC, Jones, LMCIFI. So before Docker, we used to use these containers. These containers. Okay. LXC, Linux container. This is a Linux container. Jones is the Solaris containers. LMCIFI, let me container for you, full form, right? So these are the Google containers, right? So these containers are failed. These containers are failed because these containers are platform dependent containers. These containers are platform dependent containers. Only that in that respective platform only those will be run. But Docker is not platform dependent. It is a platform independent. So it can be run on any platform, Windows, Linux, Solaris, even Mac OS also. That is why Docker is very popular now. Fine. So Docker is currently every project team, they are migrating their applications to Docker containers because so less costing, very faster, right? We can use any environment. It is a platform independent, right? So these are all advantages. So Kubernetes is advanced to Docker. Right? So while working on Docker, Kubernetes will go very deep dive. Fine. Yeah. So any other questions, anyone? So tomorrow, yeah. So far we discussed about server architecture up to here, right? So this architecture will go deep dive while working on AWS cloud. Okay. Yeah. So operating system. So from here we'll see tomorrow. Operating system and networks. This will take 1 hour, right? Up to server architecture we cover now. This will take 1 hour. So tomorrow we'll see all these things. Okay. So any new guys joined today? Can you share your WhatsApp number, email address in the chat? So my mobile number is 96422111711. So can you share your WhatsApp number, email address in the chat? Any new guys joined today? So that will provide you previous recordings and course content, and I provide you some documents also. Yeah. So WhatsApp group already created. If you are interested, you can make the fee and add into WhatsApp group. Okay. So in the WhatsApp group, we'll share all the information. So link may be changed very soon. Meeting link may be changed very soon. You can add into WhatsApp group so that we'll share all the information in the WhatsApp group only. So yeah, tomorrow, so our batch is already started. So today, tomorrow we are going to work on basics. Today already we covered servers, right? So tomorrow we are going to work on networks. So day after tomorrow we are going to start AWS. Day after tomorrow. Okay. Yeah. So meanwhile, so the people who are not attended so far, you can go through the demo sessions and you can continue. So you can add into WhatsApp group as soon as possible. Fine. So already people added, nearly 16 to 17 people already paid the fee and they added into WhatsApp group. Okay, you can take down my number. So if you have any more questions, you can reach out to me so that we'll discuss. Fine. Yeah. So we can wind up here. Fine. Yeah. Thank you all.